So in this problem, we're actually going to find the actual velocity of the plane. So they give us 45 degrees for the plane traveling, which I made a diagram and I took this and we did 45 right here. Then this is actual the plane, the wind, vectors going down, and then we took this vector right here with actual true flight time pattern, and P is going to be the plane. So in this, T vector equals P vector plus W vector. So we go down here and I redrew it just to find the vector for P. So I drew it up as 45 degrees and I made it into a right angle, which this is X and this is Y. And this would be 400 miles per hour, which the plane was traveling up. So you took cosine 45 equals X over 400, because it's cosine. Okay, and then you're going to get X by itself, which is, you're going to move it over, which is going to be 400 cosine X. 45 cosine equals X. So when you simplify that, when you do that in the calculator, you get you get 282. And I did the same thing for Y, but instead of using cosine, I use sine, which sine is 40, and it ends up working out to be the same, 282. So I got the vectors, the two vectors for plane, the plane vector. So I come up here to the wind vector. So I drew the same way out, and I did, this is going to be the miles per hour, the plane's traveling. This is going to be your Y vector, which is going to be negative because if you look on the X and Y axis, it's going down. So that value is going to be a negative. And then we take cosine 45 again, equals X over 40 this time. And we simplify that out, and it ends up being X equals 28, which is over here is the exact same thing, but it's X equals negative 28. And the wind vector is 28 comma negative 28. So then we go down here, and we're going to find the vector for the true flight pattern, what we've been looking for in the beginning. So we're going to add the vectors together. 282 plus 28, comma, 282 plus negative 28. So it ends up being 310, comma, 254, which that is the vector for the true flight pattern. Now we're actually going to get momentum of the true flight pattern. You're going to take square root of 310 squared plus 254 squared, which gives you the momentum of 401 meters per hour. And that's going to be the answer.